I'm going to be talking about tracking corporate relationships. This is a brand new project, as Supi mentioned before at the beginning of the session. And the main goal of this is to automatically track corporate access, ownership, and control relationships. And you might be wondering, why does this matter? Why is this important? And it's important for several reasons. For one, shell corporations, which are perfectly legal in most jurisdictions, can often be used for anonymity purposes to hide fraudulent or criminal activities like money laundering and tax evasion. And there's been some high-profile cases of either kleptocracy or drug money laundering that have cost billions and billions of dollars. And because this is a Department of Defense project, one of their worries is foreign influence over critical infrastructures. It can be easy to circumvent restrictions on foreign ownership and control over industries by hiding this behavior through shell corporations and complicated business relationships. And also, the financial stability of entire economies can be affected by complicated corporate ownership and liability behaviors. So for instance, in the recession, over a decade ago, there was a mismatch between how much decision power and control that holding companies had over compared to the liabilities that they imposed systemically on the entire economy. And from a computer science perspective, this is a tricky problem. There's hundreds of millions of businesses worldwide, and there isn't just one central database that we can apply some simple graph search algorithms to in order to track this kind of stuff. Each jurisdiction, including each US state, maintains their own business registry and maintains their own regulations about how these businesses need to report and operate. And not only that, over time, these entities are created, merged, and destroyed regularly. So there's millions and millions of companies that are being formed each year, and some amount that are also being destroyed each year. So the current approaches to this really fall into the realm of law enforcement and investigations or intelligence agencies. And at least publicly, a lot of this is just done with human investigators mapping out, and forensic accountants just mapping out the trails between these corporate relationships. And there's a lot of databases that collect this information, but largely what you have access to is just text-based database search. So our main goal here is to use an automated approach. And the main technique we use is automatic reasoning to try to mechanically answer queries about these corporate relationships to ease the burden on human investigators and have a multiplier effect so that a few investigators can handle more of these cases and trace these criminal or dangerous corporate relationships through giant data sets. So let's take an example, a simple example of what this might look like for a contractor. So for certain industries and certain government agencies in the US, there are regulations about how much foreign ownership a contractor or a subcontractor can have in order to get a contract with the US federal government. So for instance, if we have this company, let's just call it C Corp, it has a contract with the government, and let's just say it's completely US owned, it has no other foreign owners, but in the course of the contract, some other corporation, some other wholly US owned domestic corporation purchases this company. But if that S Corp has some amount of foreign ownership, then there's this indirect foreign influence over this government contractor. And while this simple example, you could just do this by hand. But as these relationships get more complicated and change rapidly over time, having some automated approach to track these kinds of relationships would be a boon to ensuring that regulations are followed and ensuring the safety and security of US industries. So the kind of high-level idea behind our approach is that we can take these kinds of relationships and we can model them in logic. And so we can take a question like, does a foreign corporation have any kind of influence over the contracting organization? We can frame that as a logical question, not F Corp implies C Corp, where implies means has influence over. And then for the other relationships in this graph, where we have F Corp owning part of S Corp owning part of C Corp, we can model these using logic. And then the problem becomes the classic computer science problem of just checking the satisfiability of this statement. So if we want to ask, is there foreign influence, we can use existing tools that can answer and try to prove whether this statement is true or not. So that's the main kind of high level idea. But as usual, God is in the details. Where do we actually get this data? It's not clean sensor data that we can get from a camera or from a measurement devices. This data is just from business registries that are managed by humans. And often there's lots and lots of paper and data entry being involved in this. And not only that, as mentioned before, each jurisdiction has their own database, and they don't have all the information about corporate relationships. For instance, publicly traded companies in the United States, security regulators track them and require reporting. So that's a different data set with its own meanings. Other national banks will track financial holding companies and try to measure their own financial risk. And then there's just an innumerable number of international organizations like GLIFE, the Global LEI Foundation. There's SWIFT codes if you've ever done international bank transfers. And so there's lots and lots of scattered sources. So to see a recent example of why this is such a tricky problem to deal with and why current government agencies aren't using automated approaches, during the recent COVID-19 stimulus legislation, there was billions and billions of dollars given to small businesses. And the Small Business Administration, which is a small agency tasked with managing huge amounts of money and lots of applications in a short amount of time, ended up granting billions of dollars to what are likely fraudulent or at least non-compliant requests. And there's even been prosecutions of businesses that were just doing outright fraud and lying about what their businesses were. And so in order to find such cases automatically, not only do we have to mechanize the process, but the data is in multiple data sets. So if we want to just check whether a company asking for a payroll protection loan actually had payroll, we first need to see whether it was incorporated, at least before a couple weeks ago. And there were cases where the same person was allegedly incorporating businesses just to make these requests for loans when they could not possibly have had payroll. Now, of course, these are cases that are pending. I'm not going to say whether there was any fraud or not, but you can check out these articles to see more illustrations of this. And this, and if we had automated approaches to check these things, we might be able to save the government billions of dollars in losses and fraud. And so this data is tricky to work with. There's lots of tricky computer science problems here. Instead of sensor data, these are humans entering this information. They might have typos. There might be differences in naming that look insignificant to us, like moving articles around or expanding abbreviations that just mean we can't do exact matching. We have to do some sort of probabilistic matching. And there might just be missing or inconsistent information. More subtly, what makes just pure statistical or machine learning approaches a little tricky is that these data sets also have just semantic differences. So one jurisdiction might have an incorporation date, and when that business moves to another jurisdiction, well, the registration date is not necessarily the incorporation date. So knowing the meaning of these fields and how they interrelate to each other across data sets makes this a tricky problem. So from a high-level view, our design is to abstract away these challenges as we go to higher levels of abstraction. So at the very bottom, we have just the raw data, which is inconsistent, hard to match up entities, hard to know what they are. And our idea is to use a combination of statistical and semantic approaches to resolve these entities so we can, with high confidence, identify what businesses there are. And then on top of that, since businesses often have tight relationships, for instance, through shell corporations where there's wholly owned subsidiaries, we want to group these into a kind of abstract entity that we can then finally apply automated reasoning techniques to track relationships through these groups of entities that have single control and influence. So that's the end of my talk. The main point here is that automated tracking of corporate relationships is useful because of savings, because of all the criminality involved and the utility of being able to have this transparency. Tracking this is hard, involving lots of different kinds of problems from computer science. And we're using this kind of automated reasoning approach. But that also includes classic statistical approaches to try to handle the fuzziness in the data we have. And that's all. Thanks for listening.